Do you ever stop and wonder what the heck is going on here? With this pendulum, of course. Well, heck, we've got 5 minutes to blow. Let's figure it out. Alright, here are the items that we're going to need. We're going to need something heavy, like these two bocce balls, so I'm going to measure with like a tape measure, a bag, a rope, a long pole, and a stopwatch. Of course, 2 helpers will also be needed. I got Keeve on the left and Sadie on the right, and somewhere high to hang our pendulum. Next, throw your rope over your high point. I'm using a football field goal. Tie your bag to the rope. Make sure nobody's watching. Next, you need to put your heavy object in there. I'm putting 1 bocce ball in, making sure it's there. And then I'm going to measure the top of the pendulum down to where the ball is at, where the center of gravity is at with this pendulum. We want to have the same angle or amplitude of our pendulum each time. In order to do that, I'm using this blue ball as a guide point. I'm lining it up with the pole and putting the yellow ball directly underneath. That way I know where to release it each time for this particular length. Next, pull your pendulum back to that particular spot. Get your stopwatch ready, and then start your stopwatch as soon as you let go of your pendulum. Now your stopwatch needs to record laps. Basically what I'm doing is each time the pendulum comes as close to me as possible, I record that time. I've done this a few times, now adding some more weight to switch up the experiment. Now I'm letting it go and recording laps again. Record. Record. Mission accomplished. Now I'm going to lengthen my rope and change the experiment again. Now time to put some more balls in there, gracefully. Measuring again my new length. That's going to be important for later. And I'm using the pole method again to make sure my angle is the same. See me adjust the yellow ball. And recording again. Now what you're probably noticing is that the pendulum is slowing down through its swings. And I'm going to show you exactly what's happening through this quick time lapse. Here I go, letting go. Swings a few times. You can tell it's slowing down. And here are some of the factors that are involved. Let's stop it there. First we have the momentum of our pendulum, which is represented by the green arrow. Now the friction involved from the air is represented by the red arrow. Finally, there is some friction between the rope and the pole, and that's represented by the black arrow. The effect of these 2 friction forces are slowing down our pendulum. Slower, slower. Alright, I've maxed out my ball usage, so hey, why not try something else? Sadie will work. Let's shove her in there and swing her some. And notice how when I let her go right beside the camera, she is not touching the camera, and that's because of the frictional force that we discussed earlier. She keeps on getting further and further away. Alright, I have my recorded times, I have my lengths, and I'm going to compare those between the different masses of the objects that I swung. Now here's the equation and a quick diagram of what's going on. Notice how the equation does not include anything about mass. It only includes time, length, and the gravitational constant. So I'm going to pound through these real quick and compare. And what you should get, and what I got, was that mass does not affect the period. Only length does. So now we have a better idea as far as how pendulums work. And hey, if you get the length just about right, you're going to get it to match up to just about a second. And that's how pendulum clocks work. So that's it for me, and thanks for watching. One way to assess your students is to ask them questions both during and after the demonstration. You could also slap them with a quiz, but you might get booed for doing this.